What if the universe has been trying to send us messages, but we've only just begun to listen? Imagine a sound so strange, so otherworldly, that it defies all explanation. A signal from the edge of space, echoing across the cosmos, waiting to be decoded. These aren't the whispers of science fiction. They're real, and they're as mysterious as they are fascinating. From fleeting bursts of energy to patterns that seem almost deliberate, the universe is full of signals that challenge everything we think we know. In this video, we're diving deep into the unknown, exploring 25 of the most bizarre and unexplained signals ever detected. These aren't just random blips on a radar. They're cosmic enigmas that have left scientists scratching their heads and sparked endless debates about what or who might be out there. Are these signals natural phenomena, or could they be evidence of something far more extraordinary? So buckle up. This isn't just a journey through space. It's a journey into the mysteries that lie at the very edge of our understanding. By the end of this video, you'll have a front row seat to some of the most perplexing discoveries in astronomy, and maybe, just maybe, you'll start to wonder what else is out there waiting to be found. Let's begin. Now, let's turn our attention to one of the most iconic signals ever detected, the WOW signal. Back in 1977, a radio telescope at Ohio State University picked up something extraordinary. For 72 seconds, a burst of radio waves blared through the cosmos, so strong and so unusual that astronomer Jerry Amon circled it on the printout and wrote, "Wow." Next to it, that single word gave the signal its name, and it's been a source of fascination ever since. What made the WOW signal so remarkable? For starters, it came from a region of space near the constellation Sagittarius, and it matched the exact frequency scientists had predicted an extraterrestrial signal might use. But just as quickly as it appeared, it vanished. Despite countless attempts to detect it again, the WOW signal has never been heard since. This fleeting nature has only deepened the mystery. Was it a one-time cosmic event, or could it have been a deliberate attempt at communication? Theories about its origin range from natural explanations to the tantalizing possibility of extraterrestrial intelligence. Some scientists suggest it could have been caused by a passing comet, while others argue that its characteristics don't quite fit that explanation. The idea that it might have been a message from an advanced civilization continues to capture imaginations even decades later. The WOW signal remains a cornerstone in the search for extraterrestrial life, a reminder that the universe is full of surprises, and that sometimes the most profound mysteries are the ones we can't quite solve. As we move forward, this signal sets the stage for the many other strange and unexplained phenomena we'll explore. Each one, like the WOW signal, challenges our understanding of the cosmos and keeps us asking, what else is out there? Now, let's dive deeper into the theories surrounding the WOW signal. Over the years, scientists and researchers have proposed several explanations for this mysterious burst of radio waves. One of the most debated theories is that it could have been caused by a natural cosmic event, such as a passing comet. In 2016, astronomer Antonio Paris suggested that the signal might have originated from hydrogen clouds surrounding two comets, 266P and 335P, which were in the same region of space at the time. However, this explanation has been met with skepticism, as the frequency and characteristics of the WOW signal don't perfectly align with what we'd expect from cometary activity. Another compelling theory is that the signal could have been a deliberate attempt at communication from an extraterrestrial civilization. The frequency of the WOW signal, around 1420 MHz, is significant because it falls within the range known as the water hole, a quiet band of the radio spectrum that scientists believe advanced civilizations might use for interstellar communication. The signal's intensity and narrow bandwidth also make it stand out as something potentially artificial. Yet, despite these intriguing clues, the lack of any repeat detection has left this theory in the realm of speculation. Some have even proposed that the WOW signal could have been a one-time event, such as a burst of energy from a distant star or an unknown astrophysical phenomenon. The universe is full of transient events that we're only beginning to understand, and it's possible that the WOW signal was one of these rare, fleeting occurrences. But without more data, we're left with more questions than answers. The fact that the WOW signal has never been detected again adds another layer of mystery. If it was a deliberate message, why hasn't it been repeated? If it was a natural event, why haven't we observed something similar since? These unanswered questions keep the WOW signal at the forefront of discussions about extraterrestrial life and the mysteries of the cosmos. As we continue our journey through strange signals from the edge of space, the WOW signal serves as a powerful reminder of how much we still have to learn about the universe, and how every unexplained phenomenon brings us one step closer to uncovering its secrets. Now, shifting our focus to another enigmatic signal from the cosmos, we encounter fast radio burst 121102, or FRB 121102. Discovered in 2012, this signal holds a unique place in the history of astronomy as the first repeating fast radio burst ever detected. Unlike the WOW signal, which appeared only once, FRB 121102 has been observed multiple times, making it a groundbreaking discovery in the study of these mysterious cosmic phenomena. Fast radio bursts are incredibly brief but intense bursts of radio waves that last only milliseconds, yet they release as much energy as the sun does in days or even months. FRB 121102 stands out because it wasn't just a one-time event. Its repeating nature allowed scientists to study it more closely, providing valuable clues about its origin. This signal comes from a dwarf galaxy located approximately 3 billion light-years away, a staggering distance that underscores the immense power of these bursts. The nature of fast radio bursts has puzzled scientists since their discovery. Some believe they could originate from highly magnetized neutron stars known as magnetars, which are capable of producing enormous bursts of energy. Others speculate that FRB 121102 might be linked to advanced extraterrestrial technology, perhaps as a form of interstellar communication or even a byproduct of alien propulsion systems. While the idea of alien technology is fascinating, the scientific community leans more toward natural explanations, with magnetars being the leading candidate. What makes FRB 121102 particularly intriguing is its repeating pattern. Unlike other fast radio bursts that appear once and vanish, this signal has been detected multiple times, sometimes in clusters of activity. This repetition has allowed astronomers to pinpoint its location and study its environment, revealing that it originates from a region of intense star formation. Such findings have opened new doors in our understanding of these cosmic signals and their potential sources. As we continue to explore the mysteries of the universe, FRB 121102 serves as a reminder of how much we still have to learn. Whether it's the result of a magnetar's explosive energy or something even more extraordinary, this repeating signal challenges our understanding of the cosmos and keeps us searching for answers. And as we move forward, we'll uncover even more strange and fascinating signals that push the boundaries of what we know. Now, let's take a closer look at the mystery of repeating fast radio bursts, with FRB 121102 at the center of this cosmic puzzle. What makes this signal so special isn't just its repeating nature, but the way it has transformed our understanding of these fleeting yet powerful bursts of energy. Scientists have long been fascinated by fast radio bursts, but it's the repeating ones like FRB 121102 that have truly opened new doors in astrophysics. One of the key breakthroughs with FRB 121102 is its ability to be studied over time. Unlike single bursts that disappear as quickly as they arrive, this repeating signal has allowed researchers to observe it multiple times, gathering data that would otherwise be impossible to collect. By analyzing its patterns, scientists have been able to trace its origin to a dwarf galaxy billions of light years away, a discovery that has shed light on the environments where these bursts occur. This galaxy is a hotbed of star formation, suggesting that fast radio bursts might be linked to young, energetic stars or the remnants they leave behind, such as neutron stars or magnetars. The repeating nature of FRB 121102 has also raised intriguing questions about what causes these bursts. While single fast radio bursts could be the result of cataclysmic events, like the collision of neutron stars or the collapse of a massive star, repeating bursts suggest a different mechanism. Some scientists propose that they could be caused by magnetars, highly magnetized neutron stars that occasionally release enormous bursts of energy. Others have even speculated that repeating fast radio bursts could be artificial in origin, perhaps a form of communication or energy transmission from an advanced extraterrestrial civilization. While this idea is captivating, the scientific consensus leans toward natural explanations, with magnetars being the most plausible source. What's truly remarkable is how FRB 121102 has become a cornerstone in the study of fast radio bursts. By studying its behavior, scientists have been able to develop models that help explain not just this signal, but other fast radio bursts as well. For instance, the discovery of more repeating bursts in recent years has reinforced the idea that these signals are not as rare as once thought. This has led to a growing understanding of their potential role in the universe, from probing the intergalactic medium to testing theories about the nature of space and time. As we continue to unravel the secrets of FRB 121102, one thing is clear: this repeating signal has revolutionized our approach to studying fast radio bursts. It has shown us that these mysterious signals are not just fleeting anomalies, but windows into some of the most extreme and energetic processes in the universe. And as we turn our attention to the next signal on our list, we'll see how each discovery builds on the last, bringing us closer to understanding the cosmos in ways we never imagined. Now, let's step back in time to the moment that started it all: the discovery of the very first fast radio burst, known as the Lorimer burst. Detected in 2007 by astronomer Duncan Lorimer and his team, this brief but powerful signal marked the beginning of a new era in astronomy. Lasting just a few milliseconds, the Lorimer burst was so intense that it released as much energy as the Sun does in 30 days. Yet, despite its incredible power, it vanished almost as quickly as it appeared, leaving scientists with more questions than answers. What made the Lorimer burst so groundbreaking was not just its energy, but the fact that it was unlike anything astronomers had ever seen before. It came from a region of space far beyond our galaxy, suggesting that these bursts were not local phenomena but something happening on a cosmic scale. This discovery was so unexpected that some initially doubted its authenticity, wondering if it could have been caused by terrestrial interference or an instrument error. However, further analysis confirmed that the signal was indeed real, and it opened the door to a whole new field of research. One of the biggest challenges with the Lorimer burst and fast radio bursts in general is their fleeting nature. Unlike other cosmic signals that can be observed over time, fast radio bursts are incredibly brief, making them extremely difficult to detect and study. In fact, it took years after the Lorimer burst was discovered for astronomers to confirm that these signals were not just rare anomalies, but a recurring phenomenon in the universe. This has led to the development of more advanced telescopes and detection methods designed to catch these elusive bursts in the act. Another challenge lies in pinpointing their origins. Because fast radio bursts last only milliseconds, it's incredibly difficult to trace them back to their source. The Lorimer burst, for example, was detected by a single telescope, making it impossible to triangulate its exact location. This has spurred the creation of networks of telescopes working together to capture these signals from multiple angles, allowing scientists to narrow down their origins and study the environments where they occur. The discovery of the Lorimer burst not only introduced us to the mysterious world of fast radio bursts, but also highlighted how much we still have to learn about the universe. It showed us that even the briefest signals can hold the key to understanding some of the most extreme and energetic processes in the cosmos. And as we move forward, each new discovery builds on the foundation laid by this first groundbreaking signal, bringing us closer to unraveling the mysteries of the universe. With that in mind, let's turn our attention to another intriguing signal that has captivated scientists and enthusiasts alike: SHGB 02+14a. This mysterious radio signal, detected near the constellation Pisces, has sparked debates about its potential extraterrestrial origins and what it could mean for our search for life beyond Earth. Now, let's shift our focus to a signal that has sparked both curiosity and controversy: SHGB 02+14a. Detected in the early 2000s, this mysterious radio signal has been the subject of intense debate among scientists and enthusiasts alike. What makes SHGB 02+14a so intriguing is its unusual frequency, which falls within a range that some believe could be used for interstellar communication. This has led to speculation that the signal might not be natural in origin, but rather a deliberate attempt at contact from an advanced extraterrestrial civilization. The signal was picked up near the constellation Pisces, a region of the sky that has long fascinated astronomers. Its location, combined with its peculiar frequency, has fueled theories that it could be a beacon or message from an alien world. However, not everyone is convinced. Skeptics argue that the signal could simply be the result of terrestrial interference or a glitch in the equipment used to detect it. After all, the universe is full of natural phenomena that can produce strange and unexpected signals, and distinguishing between these and potential signs of intelligent life is no easy task. One of the challenges with SHGB 02+14a is its fleeting nature. Like many mysterious signals, it was detected only briefly and has not been observed again since its initial discovery. This makes it difficult to study in detail or confirm its origins. Without additional data, scientists are left to speculate based on the limited information available. Some have proposed that the signal could be caused by a natural astrophysical process, such as a pulsar or a fast radio burst, while others hold out hope that it might be evidence of something far more extraordinary. The debate over SHGB 02+14a highlights the broader challenges of searching for extraterrestrial intelligence. It's a field filled with tantalizing possibilities but also significant uncertainties. Every unusual signal brings with it the potential for groundbreaking discovery, but it also requires careful analysis to rule out more mundane explanations. In the case of SHGB 02+14a, the mystery remains unsolved, leaving us to wonder whether it was a fleeting glimpse of something extraordinary or simply another cosmic coincidence. As we continue our journey through the strange signals from the edge of space, the story of SHGB 02+14a serves as a reminder of how much we still have to learn about the universe. It's a signal that challenges our assumptions and pushes us to explore the unknown, keeping the search for extraterrestrial life alive with every new discovery. Next, we'll turn our attention to another enigmatic signal, this time from a star that has baffled astronomers with its unusual behavior. Now, let's turn our attention to a star that has captured the imagination of astronomers and the public alike. KIC 8,462,852, better known as Tabby's star. This star, located about 1,400 light-years away in the constellation Cygnus, has become famous for its bizarre and unpredictable dips in brightness. Unlike most stars which dim in regular, predictable patterns due to orbiting planets, Tabby's star exhibits irregular and dramatic drops in light that have left scientists scratching their heads. The mystery began in 2015 when data from NASA Kepler Space Telescope revealed that Tabby's star had experienced several significant and unexplained dimming events. In one instance, the star's brightness dropped by an astonishing 22%, a change far too large to be caused by a planet. This unusual behavior sparked a wave of speculation, with some suggesting that the dips could be evidence of alien megastructures such as a Dyson sphere designed to harness energy from the star. The idea of an advanced civilization building such a massive structure around a star is both thrilling and mind-boggling, but it's just one of many theories proposed to explain the phenomenon. Another leading explanation involves natural stellar phenomena. Some scientists believe that the irregular dimming could be caused by massive clouds of dust or debris orbiting the star. These clouds could periodically block the star's light, creating the observed dips. Others have suggested that the star might be surrounded by a swarm of comets or fragments from a shattered planet, which could also obscure its light in unpredictable ways. While these explanations are less dramatic than alien megastructures, they are grounded in known astrophysical processes and remain strong contenders. Despite the many theories, the true cause of Tabby's star's strange behavior remains elusive. One of the challenges is that the star's dimming events are sporadic and difficult to predict, making it hard for astronomers to gather consistent data. Additionally, the star's distance from Earth complicates observations, as even the most advanced telescopes struggle to provide detailed insights into what's happening around it. This has led to a lively debate within the scientific community, with researchers continuing to propose and test new hypotheses. The story of Tabby's star is a reminder of how much we still have to learn about the universe. It challenges our understanding of stellar behavior and pushes us to consider possibilities that were once the realm of science fiction. Whether the answer lies in alien technology, cosmic debris, or something entirely unexpected, the mystery of Tabby's star continues to inspire curiosity and wonder. As we move forward, let's explore another signal that has puzzled scientists this time, a signal detected from our nearest stellar neighbor, Proxima Centauri. Now, let's shift our focus to a signal that stirred both excitement and skepticism in the scientific community, the BLC-1 signal. Detected in 2020 by the Breakthrough Listen project, this signal seemed to come from the direction of Proxima Centauri, our closest stellar neighbor just over 4 light-years away. For a brief moment, it sparked hope that we might have found evidence of intelligent life beyond Earth. The Breakthrough Listen project, dedicated to searching for signs of extraterrestrial intelligence, picked up the BLC-1 signal using the Parkes radio telescope in Australia. What made this signal particularly intriguing was its narrow bandwidth and its apparent origin near Proxima Centauri, a star known to host at least 2 planets, one of which lies within the habitable zone. The idea that a technologically advanced civilization might be sending signals from such a nearby star was tantalizing, to say the least. As news of the detection spread, the scientific community and the public alike were captivated. Could this be the moment humanity had been waiting for a clear sign of life beyond our planet? The signal's characteristics seemed promising. Unlike many natural radio sources which emit across a wide range of frequencies, BLC-1 was concentrated in a very narrow band, a feature often associated with artificial transmissions. This led to a flurry of excitement and speculation, with some even suggesting that we might be on the verge of making first contact. However, as with many tantalizing discoveries, the initial excitement was tempered by further investigation. Over the following months, researchers meticulously analyzed the signal, searching for any signs that it might have a natural or human-made origin. Eventually, they concluded that BLC-1 was most likely caused by human interference. The signal's characteristics, while unusual, could be explained by terrestrial sources such as electronic devices or satellites. This was a sobering reminder of how challenging it can be to distinguish between potential extraterrestrial signals and the noise generated by our own technology. The story of BLC-1 serves as both a cautionary tale and a testament to the perseverance of scientists in the search for extraterrestrial intelligence. While the signal turned out to be a false alarm, it highlighted the importance of rigorous analysis and the need to rule out all possible explanations before jumping to conclusions. It also underscored the immense challenges of detecting a genuine signal from an alien civilization amidst the cacophony of human-made radio emissions. As we continue our journey through the strange signals from the edge of space, let's turn our attention to another deliberate attempt to reach out to the cosmos, the Arecibo message. This intentional signal, sent into space in 1974, raises fascinating questions about humanity's efforts to communicate with potential extraterrestrial civilizations. Now, let's take a closer look at one of humanity's most ambitious attempts to communicate with the cosmos, the Arecibo message. Sent in 1974 from the Arecibo Observatory in Puerto Rico, this deliberate signal was a bold statement of our existence, aimed at any potential extraterrestrial civilizations that might be listening. Unlike the mysterious signals we've explored so far, the Arecibo message was not a search for alien life, but a declaration of our own presence in the universe. The message itself was a binary encoded transmission consisting of 1,679 bits of information. This number was chosen because it is the product of two prime numbers, 23 and 73, which scientists hoped would make it easier for an intelligent recipient to decode. The message contained a wealth of information about humanity, including the numbers 1 through 10, the atomic numbers of key elements like hydrogen and carbon, the structure of DNA, a graphic of a human figure, and even a depiction of the Arecibo telescope itself. It was a snapshot of human knowledge and biology compressed into a single, powerful signal. The Arecibo message was directed toward the M13 star cluster, located approximately 25,000 light-years away. While the likelihood of the message reaching an intelligent civilization was slim, given the vast distance and the time it would take to arrive, the act of sending it was symbolic. It represented humanity's curiosity and desire to connect with the unknown, even if the chances of a response were astronomically low. However, the Arecibo message also sparked significant controversy. Some scientists and thinkers questioned whether it was wise to broadcast our existence into the cosmos. They argued that sending such a signal could potentially alert hostile or advanced civilizations to our presence, posing a risk to humanity. This debate continues to this day, with some advocating for caution in our efforts to communicate with extraterrestrial life, while others believe that the benefits of making contact far outweigh the risks. Despite the controversy, the Arecibo message remains a landmark moment in the history of astronomy and the search for extraterrestrial intelligence. It serves as a reminder of our innate desire to explore, to reach out, and to understand our place in the universe. As we continue our exploration of strange signals from the edge of space, let's turn our attention to another mysterious signal that captured the world's imagination, the HD 164595 signal, detected in 2016. Now, shifting our gaze to another intriguing signal, we arrive at the story of the HD 164595 signal, detected in 2016. This mysterious signal, originating from a star located approximately 94 light-years away, sparked a wave of excitement and speculation within the scientific community and beyond. The star, HD 164595, is similar in size and temperature to our own Sun, making it an intriguing candidate for hosting potentially habitable planets. When a strong, narrow-band radio signal was detected coming from its direction, many wondered if this could finally be the evidence of extraterrestrial intelligence we've been searching for. The signal was detected by the Ratan 600 radio telescope in Russia, and its characteristics were unusual enough to warrant serious attention. It appeared to be a concentrated burst of energy, consistent with what scientists might expect from an artificial source. The idea that an advanced civilization could be transmitting such a signal captured the imagination of researchers and the public alike. Could this be a deliberate attempt at communication, or perhaps even a byproduct of alien technology? The possibilities seemed endless. However, as with many tantalizing signals from space, the excitement was short-lived. Further analysis revealed that the signal was most likely of human origin. Interference from satellites or other Earth-based technologies was identified as the probable source. This conclusion, while disappointing to some, highlights one of the greatest challenges in the search for extraterrestrial intelligence, distinguishing between signals from distant stars and those generated by our own technology. The vast array of human-made signals, from satellites to radio transmissions, often complicates the search, creating false alarms that can be difficult to rule out. Despite the eventual dismissal of the HD 164595 signal as a potential extraterrestrial message, its detection remains an important moment in the ongoing quest to find life beyond Earth. It serves as a reminder of the complexities involved in interpreting signals from the cosmos and the need for rigorous analysis to separate the extraordinary from the mundane. As we continue to explore the mysteries of the universe, signals like this one keep us vigilant, always questioning, always searching. With this in mind, let's turn our attention to another fascinating signal that has puzzled scientists for decades: the Ross 128 signal, detected in 2017. What made this signal so unique, and why did it initially raise hopes of discovering extraterrestrial life? Let's find out. Now, let's revisit the Ratan 600 signal, a fascinating moment in the search for extraterrestrial intelligence that captivated the world in 2016. This signal, detected by the Ratan 600 radio telescope in Russia, originated from the star HD 164595, the same star we just discussed. What made this detection so remarkable was its unusual characteristics: a strong, narrow-band radio burst that seemed to defy natural explanations. For a brief moment, it appeared as though we might have stumbled upon evidence of an advanced civilization attempting to communicate across the vastness of space. The excitement surrounding the Ratan 600 signal was palpable. Scientists and enthusiasts alike speculated about its potential origins. Could this be a deliberate transmission from an alien civilization, or perhaps a technological artifact, like a massive energy beam used for propulsion or communication? The star's similarity to our Sun only added to the intrigue, as it raised the possibility of a habitable world capable of hosting intelligent life. The idea that we might be witnessing the first signs of contact with another civilization was both thrilling and humbling. However, as with many signals that initially spark hope, the story took a more grounded turn. Upon closer examination, researchers concluded that the signal was most likely caused by human-made interference. Satellites, military communications, or even terrestrial radio sources were identified as probable culprits. This revelation, while disappointing, underscores a critical challenge in the search for extraterrestrial intelligence. Our own technology often creates signals that mimic those we hope to find from distant stars. The Ratan 600 signal serves as a reminder of the need for meticulous analysis and the importance of ruling out Earth-based sources before jumping to extraordinary conclusions. Despite the eventual explanation, the Ratan 600 signal remains a significant moment in the history of SETI, the search for extraterrestrial intelligence. It highlights the delicate balance between hope and skepticism that defines this field. Every signal, no matter how promising, must be scrutinized with both curiosity and caution. As we continue to explore the cosmos, signals like this one remind us of the complexities involved in deciphering the universe's mysteries and the enduring question of whether we are truly alone. With this in mind, let's turn our attention to another intriguing signal that has puzzled scientists and sparked debates: the Ross 128 signal, detected in 2017. What made this signal stand out, and why did it initially raise hopes of discovering extraterrestrial life? Let's dive in. Now, shifting our gaze to another star that captured the attention of astronomers and alien hunters alike, we arrive at Ross 128. In 2017, this red dwarf star, located just 11 light-years from Earth, became the center of attention when mysterious signals were detected emanating from its direction. The discovery sent ripples through the scientific community, as Ross 128 is one of the closest stars to our solar system, making it a prime candidate for the search for extraterrestrial intelligence. The signals observed by the Arecibo Observatory in Puerto Rico were unusual in their nature. They appeared to be narrow-band radio waves, a type of signal often associated with artificial sources. This characteristic immediately sparked speculation. Could this be a deliberate attempt at communication from an intelligent civilization orbiting Ross 128? The star itself is known to host at least one exoplanet, Ross 128b, which lies within its habitable zone, the region where liquid water could potentially exist. This added fuel to the excitement, as the possibility of life on a nearby world seemed tantalizingly close. For a brief period, the Ross 128 signal became a beacon of hope in the search for extraterrestrial life. Scientists and enthusiasts alike wondered if we were on the verge of a historic discovery. The idea of a civilization so close to us, perhaps even within reach of future interstellar communication, was both thrilling and humbling. It seemed as though the universe might be offering us a glimpse into the existence of life beyond our own planet. However, as with many signals that initially raise hopes, the story took a more grounded turn. After extensive analysis, researchers concluded that the signals were most likely caused by satellite interference. Specifically, the signals matched the frequency and pattern of transmissions from geostationary satellites, which orbit Earth at a fixed position relative to the ground. These satellites, used for communication and broadcasting, can sometimes produce signals that mimic those we might expect from an extraterrestrial source. While the conclusion was disappointing, it highlighted an ongoing challenge in the search for extraterrestrial intelligence, distinguishing between signals from distant stars and those generated by our own technology. The Ross 128 signal serves as a reminder of the need for careful scrutiny and the importance of ruling out Earth-based sources before jumping to extraordinary conclusions. Despite the eventual explanation, the Ross 128 signal remains a significant moment in the history of SETI. It underscores the delicate balance between hope and skepticism that defines this field. Every signal, no matter how promising, must be approached with both curiosity and caution. As we continue to explore the cosmos, signals like this one remind us of the complexities involved in deciphering the universe's mysteries and the enduring question of whether we are truly alone. With this in mind, let's turn our attention to another enigmatic star that has puzzled scientists for years: Tabby's star, also known as KIC 8462852. What makes this star so unusual, and why has it become one of the most talked about mysteries in modern astronomy? Let's explore. Now, as we venture deeper into the cosmos, we arrive at one of the most perplexing stars in modern astronomy, Tabby's star, officially known as KIC 8462852. This star, located approximately 1,400 light-years away in the constellation Cygnus, has baffled scientists since its discovery in 2015. What makes Tabby's star so extraordinary is its irregular and dramatic dimming patterns, which defy conventional explanations and have sparked a wide range of theories, from natural phenomena to the possibility of alien megastructures. The mystery began when astronomers noticed that Tabby's star would occasionally dim by as much as 22%. A staggering drop in brightness that no known natural process could easily explain. Stars typically dim due to planets passing in front of them, but such events cause predictable, periodic dips in light. Tabby's star, however, displayed erratic and unpredictable dimming, sometimes lasting for days or even weeks. This unusual behavior immediately captured the attention of the scientific community and the public alike, leading to widespread speculation about its cause. One of the most intriguing theories proposed to explain the star's behavior is the idea of alien megastructures. Some scientists suggested that the dimming could be caused by a massive artificial construct, such as a Dyson sphere, built by an advanced civilization to harness the star's energy. While this idea captured the imagination of many, it remains highly speculative, and most researchers have focused on more plausible natural explanations. One leading theory is that the dimming is caused by vast clouds of dust and debris orbiting the star. These clouds could be the remnants of a shattered planet or comet, or perhaps the result of a massive collision in the star's system. Observations from the Hubble Space Telescope and other instruments have provided some support for this idea, detecting evidence of fine dust particles that could scatter and block the star's light. However, the exact nature and origin of this dust remain unclear, leaving the mystery unresolved. Another possibility is that the star itself is undergoing unusual internal processes. Some researchers have proposed that Tabby's star might be experiencing extreme stellar activity, such as massive star spots or magnetic storms, which could cause irregular dimming. While this theory is plausible, it doesn't fully account for the star's most dramatic dips in brightness, leaving room for further investigation. Despite years of study, Tabby's star continues to defy easy explanation. Each new observation seems to raise more questions than answers, keeping astronomers on the edge of their seats. The star has become a symbol of the enduring mysteries of the universe, reminding us that even with all our technological advancements, there is still so much we don't understand. As we continue to monitor Tabby's star, the hope is that future observations and advancements in technology will shed light on this cosmic enigma. Whether the answer lies in natural phenomena or something more extraordinary, the story of Tabby's star serves as a testament to the boundless curiosity and determination of humanity in our quest to understand the cosmos. With this mystery still unfolding, let's turn our attention to another intriguing signal from the depths of space, the interstellar object known as Oumuamua. What secrets does this visitor from beyond our solar system hold, and could it be more than just a passing rock? Let's explore. Now, shifting our gaze to a visitor from beyond our solar system, we encounter Oumuamua, the first known interstellar object to pass through our cosmic neighborhood. Discovered in October 2017, this mysterious object sparked immediate fascination and debate. Unlike anything we've seen before, Oumuamua's elongated, cigar-like shape and unusual trajectory left scientists scrambling to understand its origins and nature. One of the most striking features of Oumuamua is its peculiar acceleration as it moved away from the Sun. While most objects in space follow predictable paths dictated by gravity, Oumuamua seemed to speed up slightly, defying expectations. This unexpected behavior led to a flurry of theories, ranging from natural explanations to the tantalizing possibility that it could be an artificial object, perhaps even an alien probe. Some researchers proposed that Oumuamua's acceleration could be explained by outgassing, a process where sunlight heats the object, causing it to release gases that act like a natural thruster. This phenomenon is common in comets, but Oumuamua showed no visible signs of a coma or tail, which are typical indicators of outgassing. This absence only deepened the mystery, leaving scientists to wonder if there was another explanation. The idea that Oumuamua could be an alien probe or even a piece of alien technology gained traction among some in the scientific community. Harvard astronomer Avi Loeb famously suggested that the object's unusual shape and acceleration might be evidence of a light sail, a device designed to harness the pressure of sunlight for propulsion. While this theory remains speculative, it has sparked lively debate and renewed interest in the search for extraterrestrial intelligence. Others have argued that Oumuamua is more likely a natural object, perhaps a fragment from a distant planetary system. Its unusual shape could be the result of a violent collision or tidal forces from a nearby star. Some even speculate that it might be a chunk of hydrogen ice, a rare and exotic type of object that could explain its lack of visible outgassing. However, without more data, these ideas remain unproven. Despite extensive efforts to detect any signals or signs of artificial origin, no definitive evidence has been found. Observations from radio telescopes, including the Breakthrough Listen project, turned up no signs of transmissions or technological activity. Yet, the absence of evidence hasn't dampened the curiosity surrounding Oumuamua. Its brief visit left us with more questions than answers, and its true nature remains one of the most intriguing mysteries in modern astronomy. As Oumuamua continues its journey into the depths of interstellar space, it serves as a reminder of how little we know about the universe beyond our solar system. Whether it's a natural oddity or something more extraordinary, this enigmatic object has opened our eyes to the possibilities that lie in the vast expanse of the cosmos. With Oumuamua's story still unfolding, let's turn our attention to another cosmic mystery, the controversial signal detected from the exoplanet Gliese 581G. Could this distant world hold the key to finding life beyond Earth? Let's explore. Now, as we venture deeper into the cosmos, we arrive at Gliese 581G, an exoplanet that has stirred both excitement and skepticism in the scientific community. Discovered in 2010, this distant world orbits within the habitable zone of its star, Gliese 581, located approximately 20 light-years from Earth. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where conditions might be just right for liquid water to exist, a key ingredient for life as we know it. What makes Gliese 581G particularly intriguing is the controversial signal detected from its direction. While the signal itself has not been definitively linked to the planet, its origin near this potentially habitable world has sparked intense debate. Could this be a sign of extraterrestrial intelligence, or is it simply a case of cosmic coincidence? The possibility of life on Gliese 581G has captivated scientists and the public alike, but the evidence remains far from conclusive. One of the primary challenges in studying Gliese 581G is its distance and the limitations of our current technology. Detecting signals from such a remote location is no small feat, and distinguishing between natural phenomena and potential signs of life requires extraordinary precision. Some researchers argue that the signal could be the result of stellar activity or interference from Earth-based sources, while others hold out hope that it might be evidence of a technologically advanced civilization. The debate over Gliese 581G's habitability adds another layer of complexity. While the planet's location in the habitable zone is promising, its environment remains largely unknown. Factors such as its atmosphere, surface conditions, and potential for liquid water are still subjects of speculation. Some models suggest that Gliese 581G could have a stable climate, making it a strong candidate for hosting life. Others caution that its proximity to its star might result in extreme tidal forces, creating a harsh and inhospitable environment. Despite the uncertainties, Gliese 581G continues to be a focal point in the search for extraterrestrial life. Its discovery has inspired new methods for detecting and analyzing signals from distant exoplanets, pushing the boundaries of our understanding. Whether the signal detected from its direction is a cosmic whisper from an alien civilization or simply a natural phenomenon, it serves as a reminder of the vast possibilities that await us in the universe. As we ponder the mysteries of Gliese 581G, let's turn our attention to another enigmatic signal, this time from a much closer cosmic neighbor. The Puritan signals detected in Australia initially seemed like a potential breakthrough in the search for extraterrestrial intelligence, but as we'll soon discover, their true origin was far more mundane and surprisingly close to home. Now, shifting our gaze from distant exoplanets to a peculiar phenomenon much closer to home, we encounter the Puritan signals. These mysterious bursts of radio waves were first detected in Australia, sparking a wave of excitement and speculation. Initially, they seemed to fit the profile of signals from beyond our world: brief, intense, and seemingly random. Could these be messages from an alien civilization, or perhaps evidence of some unknown cosmic event? The possibilities were tantalizing. The Puritan signals were first observed by the Parkes Observatory, a facility renowned for its role in tracking the Apollo moon landings. The signals appeared to originate from the sky, but their exact source remained elusive. What made them particularly puzzling was their similarity to fast radio bursts, or FRB, which are short, powerful bursts of radio waves from deep space. This resemblance led researchers to consider the possibility that the Puritans might be of extraterrestrial origin. The idea of alien communication, even if speculative, captured the imagination of both scientists and the public. However, as the investigation deepened, a surprising twist emerged. The true source of the Puritan signals turned out to be far more mundane and much closer to home. Researchers discovered that the signals were not coming from the depths of space, but were instead being generated by microwave ovens. Specifically, the bursts occurred when someone opened the door of a microwave oven before it had finished its cycle. The sudden release of energy created a brief but detectable radio signal that mimicked the characteristics of an FRB. This revelation was both amusing and enlightening, highlighting how even the most advanced technology can sometimes lead us astray. The discovery of the Puritan signal's true origin serves as a valuable lesson in the search for extraterrestrial intelligence. It underscores the importance of ruling out all possible terrestrial explanations before jumping to conclusions about cosmic phenomena. While the initial excitement over the Puritans may have been misplaced, the investigation into their source advanced our understanding of how to distinguish between natural, human-made, and potentially extraterrestrial signals. It also demonstrated the need for meticulous observation and analysis in the field of radio astronomy. As we reflect on the Puritan signals, we're reminded that the universe is full of surprises, some profound, others delightfully ordinary. This brings us to another fascinating signal, one that was initially mistaken for an alien communication but ultimately led to a groundbreaking discovery in astronomy. The story of the LGM-1 signal, or the first pulsar, is a tale of scientific curiosity, mistaken identity, and the thrill of uncovering the unknown. Now, let's journey back to a moment in history that forever changed our understanding of the cosmos: the discovery of the LGM-1 signal. In the late 1960s, a team of astronomers at Cambridge University detected a strange, repeating signal that seemed to defy explanation. The signal was incredibly regular, pulsing every 1.337 seconds with remarkable precision. This rhythmic pattern was unlike anything observed before, and it sparked immediate intrigue. Could this be the first evidence of intelligent life beyond Earth? The researchers even jokingly labeled the signal LGM, short for Little Green Men, as they entertained the possibility of an alien origin. The signal's regularity was so striking that it seemed almost artificial, as if it were a deliberate message from a distant civilization. The idea of extraterrestrial communication was thrilling, but the scientific community knew better than to jump to conclusions. Instead, they meticulously analyzed the signal, ruling out terrestrial interference and other natural explanations. What they discovered, however, was even more extraordinary than alien contact. The source of the signal was not a distant civilization but a rapidly spinning neutron star, a celestial object so dense that a teaspoon of its material would weigh billions of tons on Earth. This discovery marked the first identification of a pulsar, a type of neutron star that emits beams of radiation from its magnetic poles as it rotates. The LGM-1 signal, later named CP1919, was a groundbreaking find. It revealed a new class of astronomical objects and opened up an entirely new field of study. Pulsars became invaluable tools for astronomers, helping them test theories of gravity, map the structure of our galaxy, and even detect gravitational waves. The discovery also highlighted the importance of skepticism and rigorous analysis in science. What began as a search for extraterrestrial intelligence ended up uncovering one of the most fascinating phenomena in the universe. The story of the LGM-1 signal is a testament to the power of curiosity and the unexpected paths it can lead us down. It reminds us that the universe is full of wonders waiting to be uncovered, even when they're not what we initially set out to find. As we continue our exploration of strange signals from the edge of space, let's turn our attention to another intriguing mystery, the HD 164595 signal, which once again raised questions about the possibility of extraterrestrial communication. Now, shifting our focus to another enigmatic signal, we revisit the HD 164595 signal, a detection that once again stirred excitement and debate within the scientific community. In 2016, a team of astronomers using the Ratan 600 telescope in Russia picked up a mysterious radio signal originating from a star system approximately 94 light-years away. The signal, which lasted only a few seconds, appeared to come from the direction of HD 164595, a Sun-like star known to host at least one exoplanet. Its unusual characteristics immediately sparked speculation about the possibility of extraterrestrial origins. The signal's frequency of around 11 GHz was particularly intriguing, as it fell within a range often associated with artificial transmissions. This led some to suggest that it could be a deliberate attempt at communication by an advanced civilization. The idea was tantalizing, especially given the star's similarity to our own Sun and the potential for habitable planets in its system. However, as with many such signals, the initial excitement was tempered by the need for careful analysis. Scientists quickly began investigating alternative explanations, including the possibility of human-made interference or natural astrophysical phenomena. One of the key challenges in studying signals like this is distinguishing between genuine cosmic events and terrestrial noise. Radio telescopes are incredibly sensitive, and they can easily pick up signals from satellites, aircraft, or even ground-based equipment. In the case of HD 164595, further observations failed to detect any repeat signals, which cast doubt on its extraterrestrial origin. Eventually, researchers concluded that the signal was most likely caused by human interference, possibly from a passing satellite or military activity. The HD 164595 signal serves as a valuable lesson in the search for extraterrestrial intelligence. It underscores the importance of patience, skepticism, and rigorous verification in the face of tantalizing discoveries. While the prospect of detecting alien communication is thrilling, the reality is that most signals turn out to have more mundane explanations. This doesn't diminish the significance of the search, though. Each detection, whether it's confirmed as extraterrestrial or not, advances our understanding of the universe and refines our methods for future investigations. As we continue to explore the cosmos, signals like HD 164595 remind us of the complexities involved in this grand endeavor. They challenge us to refine our tools, improve our techniques, and remain open to the unexpected. With that in mind, let's turn our attention to another fascinating signal, FRB 180916. A repeating fast radio burst that has captivated astronomers with its unique 16-day cycle. Now, let's dive into one of the most intriguing signals in the realm of fast radio bursts, FRB 180916. Discovered in 2019, this signal stands out not just for its repeating nature, but for its remarkably consistent 16-day cycle. Unlike most fast radio bursts, which appear randomly and vanish without a trace, FRB 180916 follows a predictable pattern, emitting bursts for about 4 days before falling silent for 12 days. This rhythmic behavior has left scientists both fascinated and puzzled, as it challenges our understanding of what could produce such precise and powerful signals. The source of FRB 180916 lies in a spiral galaxy roughly 500 million light-years away, making it one of the closest repeating fast radio bursts ever detected. Its proximity has allowed astronomers to study it in greater detail, revealing clues about its environment. One leading theory suggests that the signal originates from a highly magnetized neutron star known as a magnetar, orbiting another object such as a black hole or a massive star. The 16-day cycle could be tied to the orbital motion of this system, with the bursts occurring when the magnetar is in a specific position relative to its companion. Another possibility is that the signal is produced by a neutron star interacting with a dense cloud of gas or dust. As the star moves through this material, it could generate periodic bursts of energy. While these theories offer plausible explanations, the true nature of FRB 180916 remains a mystery. What makes this signal particularly exciting is its potential to unlock the secrets of fast radio bursts as a whole. By studying its behavior, scientists hope to uncover whether all fast radio bursts share similar origins or if they arise from a variety of cosmic phenomena. The discovery of FRB 180916 has also raised questions about the diversity of signals we might encounter in the universe. Could there be other repeating fast radio bursts with even longer or more complex cycles? And if so, what might they tell us about the extreme environments that produce them? As astronomers continue to monitor this signal and others like it, they are not only piecing together the puzzle of fast radio bursts, but also gaining insights into the dynamic and often violent processes that shape our universe. With FRB 180916 offering a tantalizing glimpse into the mysteries of the cosmos, our journey through strange signals from the edge of space continues. Next, we'll explore another fascinating theory that has captured the imagination of scientists and enthusiasts alike: the alien megastructure hypothesis surrounding Tabby's star. Shifting our focus to another cosmic enigma, let's delve into the captivating mystery of Tabby's star and the alien megastructure theory that has sparked both excitement and skepticism in the scientific community. Officially known as KIC 8462852, this star first gained attention in 2015 when astronomers noticed its unusual dimming patterns. Unlike typical stars which dim in predictable ways due to orbiting planets, Tabby's star exhibited irregular and dramatic drops in brightness, sometimes by as much as 22%. These fluctuations were so bizarre that they defied conventional explanations, leading some to propose an extraordinary idea: could this be evidence of an alien megastructure? The alien megastructure hypothesis suggests that the irregular dimming might be caused by a massive artificial structure, such as a Dyson sphere, built by an advanced extraterrestrial civilization to harness energy from the star. This idea, while speculative, captured the public's imagination and reignited discussions about the search for extraterrestrial intelligence. However, the scientific community remains cautious. Many researchers argue that natural explanations such as swarms of comets, dust clouds, or even a massive ringed planet are far more likely. After all, extraordinary claims require extraordinary evidence, and so far, no definitive proof of alien technology has been found. One of the leading natural explanations involves the presence of vast amounts of dust orbiting the star. Observations from the Hubble Space Telescope and other instruments have revealed that the dimming is more pronounced at certain wavelengths, consistent with the behavior of fine dust particles. This has led many scientists to conclude that dust is the most plausible culprit, though the exact source and distribution of this material remain unclear. Some theories suggest that the dust could be the remnants of a shattered planet or a massive collision in the star's system. Despite the skepticism, the alien megastructure theory continues to inspire curiosity and debate. It serves as a reminder of how little we truly understand about the universe and the potential for discoveries that could challenge our assumptions. Tabby's star has become a focal point for astronomers who continue to monitor it closely in hopes of unraveling its secrets. Whether the answer lies in natural phenomena or something more extraordinary, this star reminds us that the cosmos is full of surprises waiting to be uncovered. As we ponder the possibilities surrounding Tabby's star, our exploration of strange signals from the edge of space takes us to another intriguing discovery: the mysterious signals detected from our nearest stellar neighbor, Proxima Centauri. What could these signals mean, and how might they reshape our understanding of the universe? Let's find out. Turning our attention closer to home, let's revisit the BLC-1 signal, a tantalizing discovery that emerged from our nearest stellar neighbor, Proxima Centauri. Detected in 2020 by the Breakthrough Listen project, this signal sparked a wave of excitement and speculation. Proxima Centauri, located just over 4 light-years away, is the closest star to our solar system and hosts at least one confirmed exoplanet, Proxima Centauri b, which lies within its habitable zone. Could this signal be a sign of intelligent life in our cosmic backyard? The BLC-1 signal, named for its detection by the Breakthrough Listen Candidate 1 project, stood out because it appeared to originate from the direction of Proxima Centauri and exhibited characteristics that seemed unusual for natural phenomena. Unlike typical radio signals from space, which are often broad and chaotic, BLC-1 was narrowband and appeared to drift in frequency in a way that mimicked the movement of a planet. This raised the possibility that it could be a deliberate transmission from an advanced civilization. For a brief moment, the idea of contact with a neighboring star system felt tantalizingly close. However, as with many mysterious signals, the initial excitement was tempered by further investigation. Researchers eventually concluded that the BLC-1 signal was likely caused by human interference, possibly from a nearby satellite or ground-based technology. While this outcome was disappointing, it highlighted the challenges of distinguishing extraterrestrial signals from the noise of our own technological activity. Despite this setback, the detection of BLC-1 remains significant. It underscores the importance of refining our methods and technologies to better identify and isolate potential signals from beyond our world. The Proxima Centauri system continues to captivate scientists and enthusiasts alike. Proxima Centauri b, the Earth-sized exoplanet orbiting within the star's habitable zone, is a prime candidate in the search for extraterrestrial life. Its proximity makes it an ideal target for future missions and observations. Could this planet, with its potential for liquid water and a stable environment, harbor life? While we don't yet have definitive answers, the possibility fuels our curiosity and drives the search for more clues. The broader implications of detecting signals from Proxima Centauri are profound. If a signal were ever confirmed to originate from this system, it would revolutionize our understanding of life in the universe. It would mean that intelligent life exists not in some distant corner of the galaxy, but right next door. This realization would have far-reaching consequences for science, philosophy, and our place in the cosmos. Even without definitive proof, the search itself reminds us of the boundless possibilities that lie within our reach. As we continue to explore the mysteries of Proxima Centauri, our journey through strange signals from the edge of space takes us to another fascinating discovery: the repeating fast radio burst known as FRB 180916. What makes this signal unique, and what could it reveal about the origins of these cosmic phenomena? Let's dive in. Now, let's circle back to one of the most iconic mysteries in the history of astronomy, the WOW signal. Detected in 1977 by the Big Ear Radio Telescope at Ohio State University, this signal has captivated scientists and enthusiasts for decades. Lasting just 72 seconds, it was so remarkable that astronomer Jerry Amon famously wrote, "Wow," next to the data printout, giving the signal its name. What made it so extraordinary was its intensity and narrowband frequency, characteristics that aligned with what scientists predicted an extraterrestrial signal might look like. Yet, despite numerous attempts to detect it again, the WOW signal has never been observed since, leaving its origin shrouded in mystery. Over the years, countless theories have emerged to explain the WOW signal. Some suggest it could have been a natural phenomenon, such as a comet or a passing asteroid reflecting radio waves. Others propose it might have been a fleeting burst of energy from a distant star, or even an artificial signal from an advanced civilization. One of the most intriguing explanations came in 2017, when researchers suggested that the signal might have originated from a sun-like star located in the constellation Sagittarius. However, follow-up observations failed to detect any repeat signals, leaving the theory unconfirmed. What makes the WOW signal so enduring is not just its mystery, but also what it represents. It stands as a symbol of humanity's quest to answer one of our most profound questions: are we alone in the universe? The fact that we've never found a definitive explanation only deepens its allure. It reminds us that, even with all our technological advancements, the cosmos still holds secrets that defy our understanding. The WOW signal continues to inspire new generations of astronomers and SETI researchers who remain hopeful that one day we might finally uncover its true nature. As we reflect on this enigmatic signal, it's worth considering how far we've come since its discovery. Modern telescopes and advanced algorithms have significantly improved our ability to detect and analyze signals from space. Yet, the WOW signal remains a benchmark, a reminder of the challenges and possibilities that come with searching for extraterrestrial intelligence. Its legacy endures not just as a scientific puzzle, but as a beacon of curiosity, urging us to keep looking, keep questioning, and keep exploring the vast unknown. With the WOW signal still echoing in our minds, let's turn our attention to another intriguing cosmic phenomenon: the fast radio burst known as FRB 190523. What sets this signal apart, and what clues does it offer about the nature of these mysterious bursts? Let's find out. Shifting our gaze to another cosmic enigma, let's explore the intriguing case of FRB 190523. Detected in 2019, this fast radio burst stands out not just for its fleeting nature, but also for what it reveals about these mysterious signals. Unlike repeating FRBs, which send out multiple bursts over time, FRB 190523 was a one-time event, adding to the puzzle of what causes these intense, millisecond-long flashes of energy. What makes this particular FRB so significant is its origin. Located nearly 8 billion light-years away, it's one of the most distant fast radio bursts ever detected. This immense distance means the signal traveled through vast stretches of the universe before reaching us, carrying with it clues about the cosmic environment it passed through. By studying such distant FRBs, scientists can learn more about the distribution of matter in the universe, including the elusive intergalactic medium that fills the space between galaxies. When compared to other FRBs, FRB 190523 offers a unique perspective. While repeating FRBs like FRB 121102 have provided valuable insights into their potential origins, non-repeating bursts like this one challenge our understanding. Some theories suggest that non-repeating FRBs could be caused by cataclysmic events, such as the collision of neutron stars or the collapse of massive stars into black holes. Others propose they might be linked to highly magnetized neutron stars known as magnetars, which can produce incredibly powerful bursts of energy. The detection of FRB 190523 also highlights the advancements in our ability to observe these fleeting signals. Modern telescopes and sophisticated detection algorithms have made it possible to pinpoint the locations of FRBs with unprecedented accuracy, even those originating from the far reaches of the universe. This progress brings us closer to unraveling the mysteries of these cosmic flashes, but it also raises new questions about their diversity and origins. As we continue to uncover more about FRBs, each discovery adds a piece to the puzzle. FRB 190523 reminds us that the universe is full of surprises, and even the briefest signals can hold profound secrets. With every new detection, we edge closer to understanding the forces that shape these enigmatic bursts and what they might tell us about the cosmos. Now, let's turn our attention to another fascinating signal, this time from an exoplanet that might be hiding a moon. What does the Kepler 1625b moon signal reveal about the possibilities of life beyond our solar system? Let's dive in. Now, let's journey to a discovery that could reshape our understanding of distant worlds, the Kepler 1625b moon signal. This intriguing find suggests the presence of a massive moon orbiting an exoplanet, marking a potential milestone in our search for celestial companions beyond our solar system. Kepler 1625b, located approximately 8,000 light-years from Earth, is a gas giant similar in size to Jupiter. What makes this exoplanet particularly fascinating is the unusual signal detected during its transit across its host star. Astronomers noticed a secondary dip in the star's light curve, a telltale sign that something large was trailing the planet. This led to the hypothesis that Kepler 1625b might be accompanied by a moon so massive that it rivals the size of Neptune. If confirmed, this would be the first exomoon ever discovered, opening up a new frontier in exoplanet research. The implications are profound. Moons, especially those orbiting gas giants, could potentially host conditions suitable for life. Think of Europa or Enceladus in our own solar system, icy moons with subsurface oceans that scientists believe might harbor microbial life. A moon around Kepler 1625b, with its immense size, could have an atmosphere, liquid water, or even geological activity, making it a tantalizing target for further study. However, the detection of exomoons is no easy task. The signals are faint, and distinguishing them from other phenomena, such as stellar activity or instrumental noise, requires precise measurements and advanced technology. The Kepler 1625b moon signal has sparked debates within the scientific community, with some researchers suggesting alternative explanations, like a second planet in the system or a ring system around the exoplanet. Yet the possibility of an exomoon remains the most compelling explanation, driving efforts to gather more data. This discovery also highlights the importance of missions like the James Webb Space Telescope, which could provide the clarity needed to confirm the existence of such moons. By studying their atmospheres and compositions, we could gain insights into how moons form and evolve, as well as their potential to support life. The Kepler 1625b moon signal reminds us that the universe is full of surprises, and even familiar objects like moons can take on extraordinary forms in distant star systems. As we continue to explore the cosmos, each new discovery brings us closer to understanding the diversity of worlds beyond our own. Next, we'll revisit one of the most enduring mysteries in astronomy, the strange dimming patterns of Tabby's star. What new insights have scientists uncovered about this enigmatic celestial object? Let's find out. Now, let's turn our attention back to one of the most puzzling stars in the cosmos, Tabby's star. Officially known as KIC 8462852, this star has baffled astronomers for years with its erratic dimming patterns. While earlier theories speculated about alien megastructures, the leading explanation now points to something far more familiar yet equally fascinating: dust. The irregular dips in Tabby's star's brightness, sometimes as much as 22%, initially sparked wild theories, including the idea of a massive alien-built structure orbiting the star. However, recent observations have shifted the focus to a more grounded explanation. Scientists now believe that clouds of fine dust particles, possibly from comets or planetary debris, are responsible for the star's unpredictable dimming. This dust theory is supported by the way the star's light behaves, specifically how different wavelengths of light are blocked unevenly, a signature consistent with dust rather than solid objects. One of the key pieces of evidence comes from the star's infrared emissions. Dust absorbs visible light and re-emits it as infrared radiation, and Tabby's star shows just that. Observations from the Spitzer Space Telescope revealed an excess of infrared light, strongly suggesting the presence of dust. Additionally, the star's dimming events are not perfectly symmetrical, further supporting the idea that the material causing the dips is unevenly distributed, much like a cloud of dust. The implications of this theory are significant. If dust is indeed the culprit, it could mean that Tabby's star is surrounded by a dynamic, evolving system of debris. This debris could be the remnants of a catastrophic collision between planets or a swarm of comets being pulled apart by the star's gravity. Either scenario offers a glimpse into the chaotic processes that shape planetary systems, even those far beyond our own. This discovery also underscores the importance of continued observation. By studying Tabby's star over time, astronomers hope to uncover more about the nature of the dust and its origins. Future missions equipped with advanced instruments could provide even clearer insights, helping us understand not just this star but the broader mechanisms at play in the universe. Tabby's star serves as a reminder that even the most mysterious phenomena often have explanations rooted in the natural world. While the allure of alien megastructures captured our imaginations, the reality of dust clouds offers its own kind of wonder, a testament to the complexity and beauty of the cosmos. Next, we'll explore another groundbreaking discovery, the first fast radio burst detected within our own galaxy. What does this tell us about these enigmatic signals? Let's dive in. Now, let's shift our gaze to a groundbreaking discovery that brought fast radio bursts closer to home literally. Meet FRB 200428, the first fast radio burst ever detected within our own galaxy. This discovery was a game-changer, not just because it happened so close to us, but because it provided the clearest link yet between these mysterious signals and a specific cosmic phenomenon, magnetars. Fast radio bursts, or FRB, have long been one of the most enigmatic puzzles in astronomy. These incredibly powerful bursts of radio waves last just milliseconds but release as much energy as the sun does in days. For years, their origins were shrouded in mystery, with theories ranging from colliding neutron stars to alien civilizations. But FRB 200428 changed the game. Detected in April 2020, this burst originated from a magnetar located about 30,000 light-years away in the Milky Way. Magnetars are a type of neutron star with an incredibly strong magnetic field trillions of times more powerful than Earth. They are known for their violent outbursts, but until FRB 200428, no one had definitively linked them to fast radio bursts. This discovery was like finding the missing piece of a cosmic puzzle. The burst was accompanied by X-ray emissions, a hallmark of magnetar activity, providing strong evidence that at least some FRBs are produced by these highly magnetic stellar remnants. What makes this discovery so significant is that it offers a tangible explanation for at least one type of FRB. While not all fast radio bursts may originate from magnetars, this finding suggests that these extreme objects are capable of producing such signals. It also opens the door to understanding the mechanisms behind FRBs. Scientists believe that the intense magnetic fields of magnetars could twist and snap, releasing enormous amounts of energy in the form of radio waves. This process, known as a magnetic reconnection, might be the key to unlocking the mystery of FRBs. the implications of this discovery are profound. By studying FRB 200428 and its magnetar source, astronomers can refine their models of how these bursts are generated. This, in turn, could help explain other FRBs detected across the universe. It's a reminder that sometimes the answers to the cosmos' biggest mysteries are hiding right in our own galactic backyard. As we continue to unravel the secrets of fast radio bursts, one thing is clear. The universe is full of surprises, and even the most fleeting signals can hold the key to understanding its deepest workings. Next, we'll reflect on the legacy of one of the most iconic observatories in the search for extraterrestrial signals, the Arecibo Observatory, and how its story continues to shape our quest for cosmic answers. Turning our attention to a moment that shook the scientific community, we arrive at the story of the Arecibo Observatory. In December 2020, the world watched in disbelief as this iconic telescope, a symbol of humanity's quest to understand the cosmos, collapsed. For more than 5 decades, Arecibo stood as a beacon of discovery, its massive dish scanning the skies for signals that might reveal the secrets of the universe or even signs of extraterrestrial life. Its loss was not just a blow to astronomy, but a poignant reminder of the fragility of our tools in the face of time and nature. Arecibo's contributions to science are nothing short of monumental. Built in the early 1960s, it was the largest single-aperture telescope in the world for much of its existence. Its most famous achievement came in 1974, when it sent the Arecibo message, a deliberate signal aimed at potential extraterrestrial civilizations. This message, encoded with information about humanity and Earth, remains one of the most ambitious attempts to communicate with the cosmos. Beyond this, Arecibo played a crucial role in detecting pulsars, mapping asteroids, and even studying Earth's atmosphere. It was a workhorse of astronomy, providing data that shaped our understanding of the universe. But Arecibo's legacy extends far beyond its scientific achievements. It became a cultural icon, inspiring generations of scientists and dreamers. Its towering structure, nestled in the lush hills of Puerto Rico, appeared in films and captured the public's imagination. For many, Arecibo was a symbol of hope, a reminder that we are part of something much larger than ourselves. Its collapse, caused by structural failures after years of wear and limited funding, was a stark wake-up call about the need to invest in and preserve our scientific infrastructure. The loss of Arecibo has left a void in the search for extraterrestrial intelligence, or SETI. While other observatories like the Green Bank Telescope and the upcoming Square Kilometre Array continue this work, Arecibo's unique capabilities are irreplaceable. Its ability to detect faint signals from distant stars made it a key player in the hunt for alien civilizations. Without it, the search has become more challenging but not impossible. The collapse has also sparked a renewed focus on building more resilient and advanced telescopes, ensuring that the next generation of observatories can carry on Arecibo's mission. As we look to the future, Arecibo's legacy serves as both a cautionary tale and a source of inspiration. It reminds us of the importance of curiosity, collaboration, and perseverance in the face of the unknown. While the telescope may be gone, its impact lives on in the discoveries it made and the dreams it ignited. The search for extraterrestrial signals continues, driven by the same spirit of exploration that defined Arecibo's remarkable journey. And as we move forward, we carry with us the lessons of this iconic observatory, striving to build a future where the mysteries of the cosmos are within our reach. Now, as we wrap up our exploration of these 25 strange signals from the edge of space, let's take a moment to reflect on what they reveal about our place in the universe and the endless possibilities that lie beyond. As we bring our journey through these 25 strange signals from the edge of space to a close, it's clear that each one offers a unique glimpse into the vast and mysterious cosmos. From the enigmatic wow signal to the repeating bursts of FRB 121102, These signals challenge our understanding of the universe and ignite our curiosity about what or who might be out there. They remind us that the cosmos is full of surprises waiting to be uncovered by those who dare to listen. These signals are more than just anomalies, they are windows into the unknown. They push the boundaries of science, forcing us to rethink our assumptions and explore new possibilities. Whether they originate from natural phenomena or something more extraordinary, each signal carries the potential to reshape our understanding of the universe and our place within it. They remind us that the search for extraterrestrial life is not just a scientific endeavor but a deeply human one, driven by our innate desire to connect with something greater than ourselves. But the story doesn't end here. The mysteries of the cosmos are far from solved, and every discovery raises new questions. What lies beyond the next star? Could one of these signals be the key to unlocking the secrets of extraterrestrial life? The answers are out there, waiting to be found. And as we continue to explore, we carry forward the legacy of observatories like Arecibo, building on their achievements and striving to uncover the truths hidden in the depths of space. So, what do you think? Could one of these signals be the first sign of life beyond Earth? Or are they simply cosmic phenomena we have yet to fully understand? Share your thoughts in the comments below. We'd love to hear your theories and ideas. And if you're as fascinated by these mysteries as we are, don't forget to subscribe and hit the notification bell for more deep dives into the wonders of the universe. The cosmos is vast and the journey is just beginning. Let's explore it together.